Right, we are going to do VXLAN maybe in 2 or 3 parts. We got this 4 leaf and 2 spines, and we got 3 servers. Server 1 is connected to leaf 1, server 2 is connected to leaf 3, and server 3 is connected to the outside of our VXLAN fabric. It is behind a WAN. So our aim in this lab is to see how we can configure VXLAN and how can we have an EVPN as a control plane, and then how the routing between the servers within the fabric and routing between the servers outside the fabric can be done. So if you understand these things, in any topology you can deploy VXLAN. Routing within the servers, between the servers that are within the VXLAN fabric. Example, between server 1 and server 2, when I ping, that is achieved. And when I ping between server 1 to server 3 or server 3 to server 2, outside to inside and inside to outside, I can talk to WAN via VXLAN fabric. In the real world, instead of server 3, you may have some destinations to go in the internet. The IP addresses that we see here are loopback 0 interface IP address. If you see, loopback 0 has got .8, .9, .10 and .11. Loopback 1, we are going to use it for some special services like anycast, multicast, anycast, multicasting, anycast RP, and many more things like gateways. We are going to use pervasive gateway and so on. So our focus is on the loopback 0 interface address. For spine and the leaf, the loopback interface addresses are as follows. Starting from 06. 06 is the loopback address, loopback 0 interface address of spine 1. 07 is spine 2. 8, 9, 10, 11 are leaves. Easy to understand, easy to know, easy to remember. Spine 1 is .6, WAN is .5. So they have given numbers starting from WAN. WAN .5, loopback 0 of WAN router is .5, .6 is spine 1, .7 is spine 2, 8, 9, 10, 11 is leaf. We will not have any confusion here. Starting from 5, that's all. WAN is the starting router. After WAN comes spine, after spine comes leaf. The server's IP address will be later mentioned in our workbook. Fine, and these are the IP addresses and the credentials to log in to manage the device. And we have already got those sessions. I'm on spine 1. Spine 1, according to the lab guide, I need to use admin as the password and C1SCO12345 as the password. Admin, capital C1SCO12345. I'm inside the spine. Now, if you see the topology here, between the leaf and spine, we need Ospf because underlay is layer 3, and the fast converging routing protocol, the reliable routing protocol most of the people use is Ospf. So we got Ospf already configured. I would like to go and verify whether it is really configured or not. So I type this command show IP Ospf neighbor. Look at this, the same IP address that you saw there. .8, .9, .10, .11. These are the 4 router IDs of leaf. .8, .9, .10, .11. So spine has got Ospf neighborship with 4 leaf. Likewise, let me check from spine 2. Admin C1SC. Oh, sorry. Spine 2. C1SC. Oh, 1, 2, 3, 4, 5. Here also I would like to use the same command to see the Ospf neighborship. Show IP Ospf neighbor. You see, same 8, 9, 10, 11. You will not see spine here because there is no connection between spines. Now if you see this output, then you are ready to start the lab. Chapter 2 is the place from where the actual lab starts. Establish Ibgp peer between the spine and the leaf. That's what the first thing that we are going to do. After I finish configuring, I should see this. And if you see, the neighbor addresses are using loopback interface. Yep. So let's see how to configure. First, let's start from spine. See here, what we do is, if you know how to configure BGP and the peer group in router, similar way we are going to configure here. Nexus is like a mixture of Cisco IOS router and ASR router. Why do I bring ASR in picture here? In ASR only we used to enable the address family, and then we go under the neighbor, again we enable address family.
So this address family I Googled actually, this address family IDP or
So like you go under BGP, in iOS we do here under the router ID, the loopback interface address, we give address family. This address family, first address family is to start the IPv4 support, BGP's IPv4 support. See, BGP is not a protocol for IPv4 alone. BGP has got a lot of modules. One will support IPv4, the other will support IPv6, the other will support EVPN, the other will support VXLAN, the other will segment routing, the other will support VPLS. That is why we call MP multi-protocol BGP. BGP is not one protocol, it is multi-protocol. So you need to say what protocol in BGP you want. I want IPv4 package of BGP. So I say address family IPv4 uniqueness. Globally I am enabling the IPv4 package of BGP. And then by calling this template under each neighbor, I am going to put each neighbor under that address family IPv4. So this address family is for the neighbor to make membership. See, you may have multiple address families. You may have IPv4 address family, IPv6 address family. So for some neighbor you may like to have IPv4, for some neighbor you may like to have IPv6. So you need to mention which address family you want to give for the neighbors. In our case, for all neighbor, we got 4 IBGP neighbors from spine. All 4 need to be IPv4 address family supporting device. Question, please.
I go with the point. Regarding this address family IPv4, in case I got the point.
Okay. So then
And other thing is, what is this incumbency?
Okay, see, we are going to have a VRF for providing multi-tenants. So each tenant route need to be kept separate. For that, we will be using route distinguisher and route target for VPN customer traffic. In VPN, when customer traffic goes, to keep it separate, we have route targets. So route targets are community values that need to be carried along with the BGP's update. So we say send community both. If you don't do this, then VPN will not carry the BGP updates.
Okay.
And the reason why we have route reflector is the spine is there in the middle between these two leaves. There is a rule in BGP called Ibgp split horizon rule. The rule says the route that you learn from one Ibgp should not be given to another Ibgp. Meaning, anything that you learn from leaf 1, you should not give to leaf 2, leaf 3, leaf 4, leaf 4. So spine should not give. We make the spine to give by putting route reflector. So we go to spine 1 and spine 1, it's okay, you can give. They are all your clients only. By default, BGP rule won't allow route learned from one IBGP to be given to another IBGP. We force it to give it by overriding the default IBGP split horizon rule. Question, please.
Okay, this BGP split horizon is mentioning that the routes which is starting from leaf 1 will be now reflected by spine 1 and spine 2 to all other leaves. Likewise, the route learned from leaf 2 will be reflected to 1, 3 and 4 by both the spines. Yeah.
Fine.
And between spine 1 and spine 2
we will not have any IBGP neighborship. No IBGP session between leaves, between spines. It is only via spine. So let us now do this. Do you understand all these commands?
Yes. I know this.
Okay. Okay. So then we will go under each neighbor and call this peer group. Inherit this peer group. So let me start from the spine 1 now. Spine 1, show IP BGP summary. See, right now I don't have any BGP running, and I'm going to run now router BGP.
For that, can you show me the configuration?
OSPF configuration. Okay. Sure, and it's a simple OSPF with loopback interface, loopback 0 as a route ID. Show run section OSPF. No need of section. This is not a router. Just type like this, it will come. So what we see is under each interface the OSPF is enabled. You see router OSPF 1 and the router ID. And we don't use the network command. We go under the interface and we put IP OSPF process ID 1, area ID is 0. Area ID, this is the format. You need to type in 32-bit format. And then the network type is point-to-point, that will avoid DRB redirection. Yeah?
Okay.
Right, shall we get into BGP now?
Yeah, okay.
Router BGP, and the autonomous system number that we are given to use is 6500, 6500, and then the router ID, we want only the loopback 0's router ID, so I copy loopback 0, so it's the same router ID what the Ospf is using. I give it, and address family IPv4 unicast, and then we are going to create the peer group. The peer groups are called here as templates. Okay, after enabling the address family, it should come out. It's not mentioned here. It should come out of this address family. It is already enabled now. Now we should say template for peer group, for peers. I'm going to give a name like Ibgp. Simple, any name. And then I'm going to say update source loopback 0. And then update source loopback 0. And then all the peers need to be under the address family IPv4 unicast. And then send the community. Send community both. So it will be available only under the address family. Alright, so this is important. This is important. What else is missing? What else I'm missing? Update source is done. Address family is done. Community is done. What is next? No, remote is this very important command. I forgot. All the Ibgp neighbors. So remote is same 65000. Anything else important I missed? Update source loopback 0. Address family segment. Oh, reflector, route reflector. So route reflector will also come under the address family only. So route reflector client. Alright, that's it. Now we need to just inherit this for neighbors. So I got 4 neighbors. Neighbors are starting from 8, 192.168.0.8. 8 is leaf 1. Neighbor this, inherit. Sorry, I think inherit will come first. No. Then I should simply say neighbor and the neighbor address. Inside the neighbor, I'm going to say inherit the peer template Ibgp. That's it. We have done. Likewise, I'm going to inherit for other neighbors 9. Oh my god, I said already. Again, I said 8. I want to go into 9. 9 inherit same, and then neighbor 10 inherit the same, and the last Ibgp neighbor will be 11 inherit the same. Now after finishing all this, what we have to do is save, copy, run, start. Write to memory won't work on Nexus. Copy, run, start. Okay, PGP is done. I'm just going to copy this to the spine 2 because it's the same configuration. I don't want to do manually one more time. So going to spine, before that let me copy show run BGP. So this is what we did. I'm going to copy all this to spine 1. So spine 2, right? So spine 2 is also ready. What mistake I did is the router ID. That's very bad. The router ID of spine is 7. It's very important, otherwise it will conflict. Oh, write to memory won't work. Copy, run, start. Okay, what is left? Leaves. In leaf also we are going to do similar job. Admin. The password is C1SCO1234 So if I'll configure on one leaf, I can paste it on all the leaves because the leaves have got same 2 upstream spine. In the lab guide, they have not used inherit peer group, but I'm going to use inherit peer group for spine. Sorry, for leaf. Here they are doing everything under the neighbor statement, remote as update source, address, families, and community. But I'm going to use a template. So let's go to leaf and configure. Router BGP 6500, right? Yeah, 6500. That's right. 65,000. And then router ID is there was 192.16808. 0.8. 192.16808, and then address family IPv4 unicast. Come out of this, and then we are going to create a template. So I'm going to say template, peer template, Ibgp, or any word I can say. And remote AS is the very first command I should do, 6500,000. And then address family IPv4 unicast. Send the community both. And one thing I forgot to say is update source Lubak 0. That should be out of this address family. So update source Lubak 0. Is there anything I left? Send the community both, address family, update source. That's it. Nothing more. Now we are going to call this for 2 neighbors. The first neighbor is .6. .6 inherit peer Ibgp. That's all. Likewise, I got another neighbor .7. That is another spine. I inherit the. That's it. Now let's say copy, run, start. Now what I'm expecting is 2 BGP neighbor from here, from leaf. I should see 2 BGP session with 2 spine, and from spine I should see 4 BGP sessions. Show BGP. Show IPBGP summary. I see 2 successfully. Now I'll go to spine and check the same. Show IPBGP summary. I should see 4. Why? Oh, I did not paste, you see, I just configured only leaf 1. My bad memory. So I'm going to just copy and paste, that's all. Show run. We have not pasted in other leaves. Show run BGP. So I'll copy to a notepad. I need to just change the router ID. I need to just paste the router ID, change the router ID and paste on other routers. Am I right? Yes. So this is going to be 9 here for the next leaf. Enable, I think, config T, and then here I'm going to say end copy run start.
You give the comments in community both, right?
That automatically will take like this. It's okay. That's okay. That is how it the iOS will take. It takes as extended and standard. That's normal output behavior. Admin C1 SCO 1 2 3 4 5. Paste. Likewise, leaf 3 is going to have 10 here. Admin C1 SCO 1 2 3 4 5. I changed to 10 so I can paste. And the last leaf, admin C1 SCO 1 2 3 4 5, and this need to be 11. Done. So what I'm expecting is on spine I should see 4 neighbors now. One more, just one more. One more. Open send. Good, it's working. Finished. So we have finished Ibgp. We have finished, and we are able to see this. Next is multicasting, which we'll do in the next class.